Right, so the first problem from today's biweekly contest, count subarrays of length 3 with a condition. So we given an array and we are told that we want to find all the subarrays of length 3 where the first and the third element sums up to exactly half of the middle element. Exactly half, so which means this must be divisible by 2 so that it is exactly half, and the sum should be equal to the middle element's half. So we can just do the exact same thing which the question is asking. Alright, and from here I'll start nums.size. Since we are checking for 3 elements, I only need to go up till remaining last 3 elements. And if nums of I plus 1 more 2 is equal to 0 and nums of I plus 2 is equal to nums of I plus 1 by 2 answer plus plus. I want to find all the subarrays and that's it. Linear time, constant space. Moving on to the second question, count paths with the given XOR value. We're given a 2D matrix grid and you want to move in the forward direction or the, in terms of in this direction or in this direction, down direction or right direction, and we want to reach the destination node, that is I m minus 1 n minus 1, and we want to find every element's XOR value such that it is ending up equal to k by the time we reach the destination node. Simple DP problem. I think we can do just a top-down DP. Bottom-up would require some thinking, but the constraints are pretty small, and we can minimize this to down to something like m cross or m into n into 16 states. So time complexity will be around m into n, and let's code it up. Return solve function for zeroth. We'll start from 0 0, so that is the index. We need to store the value of the XOR at any point of time, and grid needs to be passed, value of k needs to be passed. This will return us integer, row, column, grid needs to be passed. So let's get the grid here, and finally k I can pass it by reference, won't be changing. So if it is out of, if it's not valid row or column, then if row is less than 0 or row is greater than equal to grid.size, or column is less than 0 or column is greater than equal to grid 0.size, in that case return 0. If destination is reached, that is grid dot size minus 1 and column is equal to grid of 0.size minus 1. At this point, if num, I should also take the XOR value, so let me take that as probably this XORs. If XOR of current element, grid of row column, in that case if it is equal to k, then we have done it. Return this as one of the paths. We want to find all the other paths, else there is no other way. Return 0. right? And then we can just do for the two remaining parts, solve. This will be row plus 1 comma column. Let's pass the XOR value as well, XOR of XORs, comma grid k. Similarly, let's copy this up for the other direction, row comma column plus 1, column plus 1. That's it. Let's see if this works, and we will minimize it. Okay, there's some problem. Let's do this, and yeah, let's see now. Yeah, probably the brackets, because the precedence of XOR is higher than the equal to sign. So let's have the cache vector of vector of vector. Let's take this outside so that I don't need to pass it. Cache. Let's resize it inside. Size will be grid dot size plus 1 comma vector of n grid of 0 dot size plus 1 comma vector of int. This can be of size, the XOR is a state. This can be maximum of value 16 as per the constraint. So let's write 16, actually 15. So I can write 16 to handle all the cases. Initial value minus 1. At this point, if cache of row, column, and XORs if it is not equal to minus 1, return that. And also do this. By the way, the value can be big, the sum value can be big, so let's XOR, mod it. Let's have a mod value, and let's mod this. Let's mod the entire thing as well. Let's see now if this works out. Time complexity will be m into n. Space complexity will be also m into n. This works. The third question, check if grid can be cut into sections. This was a very good question, very nice question. Easy, but some edge cases. We're given a grid box in which we have coordinates, right? The box is of this size n comma n, and we have points which represents the bottom left and the top right points of a rectangle, and we have different rectangles, and we want to find such that I can have two lines separating the box into three sections, either horizontally or vertically. All right, if I can get it either way, then I return for true, otherwise I return false. So there can be scenarios where I can only make two cuts, two sections as uh, uh, at max I can just have two sections. In that case, I should also return false. So the split needs to be keep tracked, and let me give an example of two split. Suppose this is the box and I am at this point, this is 0, 0. Suppose I have this as a rectangle, this as a rectangle, and this is a rectangle, and this is a rectangle. The max split that I can do horizontally or vertically is this, just in two sections. This is one text section, this is two section. Vertically, this is one section, this is two section. Only two splits or two sections, so I should return false. Uh, on top of that, there can be scenarios like this, where I have a rectangle, I have something of rectangle like this, there are overlaps, and then I have a rectangle like this, or probably let me take it this way. Sorry for the bad drawing, but you can see horizontally I don't stand a chance. I cannot have a single split because this is overlapping, and by the way I need three splits, so not even one is possible horizontally, but vertically yes, there is a split. So even if it's overlapped, I can still move forward and find other splits that I can eventually have. So there's that. This is one of the scenarios. And the basic thing that we need to do, and it's kind of very intuitive, is we can see the problem in two sections, for the horizontal split and for the vertical split. Let's see for the horizontal split. Suppose this is the example, right? Here, if I want to divide or separate the coordinates or intervals, if I must say, into this way, into this visualization where this is a rectangle, this is another level, this is another level, right? That is nothing but that's nothing but 0, 2, 0, 2. That's one level. 2, 4. That's 2 to 4. That's another level. 3 to 5. 3 to 5 is this level. 3 to 5. Oh, sorry, not 3 to 5. 2 to 3. 2 to 3 is this rectangle, this level, and then 4 to 5. Sorry, 0, 4, yeah, 4 to 5. So 4 to 5 is this level. So I can divide this interval, this horizontal intervals, into an interval, or let me call it horizontal intervals. Horizontal intervals. This will be nothing but the first index and the third index. So 0, 2, 2, 4, 2, 3, and finally 4, 5. Now, similarly, if I look at the vertical indexes in the same manner, vertical levels, then I can see that I will get something like the first coordinate and the third coordinate. Likewise, this one, vertical, the first coordinate, the zeroth coordinate is 1, 5, 0, 2, 3, 5, 0, 4. Alright, now if I try to see this and try to this can be out of order, right? We don't have any order maintained here. But if I want to maintain the order in this way, 0 to 2, 2 to 4, 4 to 5, and also notice that In the second level, we have 2 to 3 as well, but still we are going for 2 to 4 because there's no way we can do any other way because the greater rectangle will be overlapping the split line. That's why we go for the larger level that is there. So that's nothing but a sort on the x coordinate on the ascending order in ascending order and a sort on the y coordinates or I should say the second coordinate, the second index in descending order. I shouldn't say this as y or x coordinate now, but the first and the second index. So first index sort ascending on first index and or I should say zeroth index and descending if the first element is equal. Suppose 2 to 4, 2 comma 4 will come first and then 2 comma 3 will come. Why we are doing this? That will basically help us to split in the right way, right? It will make our job easier when we try to find the splits. So here, if first element equal, then sort on second element in descending. All right, and do the same thing for both the intervals. Do the same for both intervals, right? So for both the sorted intervals, we need to find the splits, right? That will get us the horizontal splits if it's possible or the vertical splits if it's possible. Let's do that for one of this way and the other way will be inherently done. So let's do the horizontal split. Suppose we have this, we have this, we have this. Now since we have sorted it in the right order, we will always get the first interval as the largest section that is there for that particular level. So for this level, this is the largest section. For this level, this is the largest section 2 to 4. For this level, this is the largest section. I'm sorry. So we can start from here and get the lower and upper limits. The next element should be either all within the first element or the lower and upper limit, or it should be completely outside the lower and upper limit. If it is completely outside the lower and upper limit, in that case we can just we can just increase the split because we have found a split point. Or the other scenario would be if there are overlaps. Suppose this was 1, should I say this was 3 and this was 4. Yeah, suppose this is what it is. In that case, this and this is overlapping. Or suppose, let me make it more interesting, 5 to 6. All right. So at this point, I'll get the lower and upper limit as 0 and 2. This one is bigger outside the range, right? It's greater. The upper limit of the previous element is greater than or equal, smaller than or equal to the lower limit of the next element. So it is fine. It is a split. It's a valid split. So I'll count the split and I'll move forward. This is not a valid split. This is overlapping. So I'll increase the upper limit from 4 to 5. At this point, my upper limit will be 4. And then my upper limit here, when I encounter this, should be 5 and my lower limit should be 2. And then I will find that this is again outside the range. So I'll increase the split. And by the end, I should have, I'm sorry, I should have the split as greater than 2, right? Greater than or equal to 2. Or I should say that I should have 3 sections, greater than equal to 3. I can have more sections, but I should have at least 3 sections. I'm sorry, my throat is bad. So let's get the two intervals first. Uh-oh, I mistakenly submitted. Okay, alright. Let's get the intervals from rectangles. I'll get, I should get two elements, so it should be a vector of vector. The first element and the third element. Similarly, the fourth and the, sorry, this should be 2, this should be 3, the first and the third element. In the second interval, and then I should just check for, I should sort it both, and I should do the processing. So let's call that processing function as is overlap. It will tell if it's overlapping or not, or is valid split. Let's call it is valid split. Let's pass the intervals. So I'll pass the interval 1, or this should be true, or the other one should be true. So it will return Boolean value. So first I'll sort. So let's sort it. Next I will sort it. I'll have a comparator. So if LHS of 0 is equal to RHS of 0, then I'll do a descending sort on the second element. That is, LHS of 1 is greater than RHS of 1. I should return LHS of 0 is less than RHS of 0. That's the ascending sort. So next thing is I will have a count on split. Initially I'll count the split as 1 because there will be at least one split. I'll get the lower limit and upper limit as well right here. Alright, at this point I will iterate from the first element because the 0th element is already processed. First I will check if this current element is within the lower and upper limit or if it's outside. So if it's overlapping, in that case I should increase the upper limit, right? So I'll handle that scenario here. So if lower limit is less than intervals of I and 0 and the upper limit is greater than intervals of I and 0, this means that this particular value is between upper limit and lower limit, and the other value that is intervals of I1 should be greater than the upper limit so that it is exactly overlapping, right? It's overlapping, not even exactly. Perfect overlap, not border overlap, but perfect overlap. This should be greater than the upper limit. In that case, this is overlap. I should increase the upper limit. Else, if the next value is greater than the upper limit, right? Greater than or equal to the upper limit. Upper limit is less than equal to intervals, which means it's a valid split. I should update the lower limit, I should update the upper limit, and I should update the uh, intervals, and I should increment the split. Intervals, I don't know why the spellings are wrong. Finally, I should return if splits is greater than equal to 3. Only in that case, this is a valid split. So yeah, let's see if this works. There should be intervals 1, intervals 2. Let's see if this works. Split, not splits. Or I should say section instead, that's a better word. Section should be greater than equal to 3. Okay, there is a problem. This should be intervals 2 and not 1. Let's see now. Yeah, it seems to work. So the time complexity will be O of n log n because I'm sorting, and otherwise it's linear. So it should be O of n log n. So these are the 3 problems. I don't have the 4th problem, at least as of now. So yeah, thanks.